Hi guys, welcome back to part 2 of the section on parabolas. Back in part 1 we learned what a parabola was. It's a graph of a function of the form y of x equals ax squared plus bx plus c, where a, b and c are fixed numbers and also a does not equal 0. We also learned that when we graph the function y equals x squared, this is a parabola with a equals 1 and b and c both equal to 0. When we graph this parabola, when we draw its graph, it looks pretty much like this. Let's see if I can draw it. It's kind of got a curve to it, and that should go through 0, 0 at the bottom there. Okay, well, now we're going to multiply it by a constant, basically. We're going to multiply it by a constant and see what happens to it. So, first, let's plot some values of x. So this is x equals 1, 2, 3, I suppose. So when x equals 1, y is equal to 1. And on the other side, when x equals negative 1, y is equal to 1. When x equals 2, y is equal to 4. And conversely on the other side, not conversely, what does conversely even mean? And also on the other side, x is equal to negative 2 also gives y equal to 4. And finally, when x is equal to 3, y is equal to 9. And also when x equals negative 3, y is equal to 9. Okay, so that's all well and good. Let's check out the case now where we have y, maybe I shouldn't write it there, y equals 1/2 x squared. Y equals 1/2 x squared. So we're multiplying it by a half this time, and we're going to see what happens. Well, straight away, basically it's y equals 1/2 x squared. Well, all we've really done is times this thing by a half. So what should happen is the value should decrease by half. And that's exactly what does happen. We'll double check it just to make sure. But suppose x equals 0. Well, y is equal to 1/2 times 0 squared. So y of 0 is 0, and our parabola goes through the point 0, 0 as well. But now when x is equal to 1, y is going to be equal to 1/2 of 1 squared. And 1 squared is 1, so y equals 1/2 of 1, which is exactly a half, 0.5. So it's going to be halfway along. It's going to be halfway along here. It's going to be halfway along this line. And that's exactly where we expected it to be, because we're literally just taking this thing and timesing it by half. We're dividing the y value by 2. Alright, similarly, when x is equal to 2, y is equal to 1/2 of x squared. So it's 1/2 of 4, which is 2. So when x is equal to 2, y is equal to 2, and our parabola goes through the point 2, 2. Finally, when x is equal to 3, y is going to be equal to half of 3 squared, which is half of 9, which is 4.5. It should be like halfway along this line. So this distance here, once again, this distance here and this distance here should be the same, even if it doesn't look like that the way I've drawn it. Okay, so that's pretty much how a parabola is going to look. You can fill in the rest of the points. You'll find out that it takes this kind of shape here. And similarly, when x equals 4, y is going to be half of 16. So it's going to be 8 when x equals 4. And anyway, that's the shape of our parabola. It's kind of like the parabola y equals x squared, except it's fatter, because by timesing it by a half, we're literally dividing all the y heights by 2. So all of a sudden, it's going to come downwards, and that's going to cause it to fatten out a bit. And for the same reason as before, when you square a negative number, you still get a positive number, because negative times a negative is a positive. It's going to look exactly the same on the other side for all the negative values of x. as a mirror reflection, if you like, in the y-axis. Alright, so that's the parabola y equals 1/2 x squared. What we're going to do now is choose a different constant. I may as well do this in red. So let's take a look at the graph of y equals 2x squared. So now we're multiplying it by the constant 2. What's going to happen to that one? Well, exactly the opposite effect actually. Instead of the y heights being halved, they're going to be doubled this time. I shouldn't write it there. It's kind of confusing next to that one. So I'll write it here. Y equals 2x squared. So multiplying x squared by 2 is going to double the y values. So that's actually going to make our parabola much skinnier because it's going to increase much faster. Let's see that. Y of 0 is still 0, however, because 2 times 0 squared is still 2 times 0, which is 0. Y of 1 is going to be 2 times 1 squared. So it's going to be 2 times 1, which is 2. We're already at 2. Y of 2 is going to be 2 times 2 squared, so 2 times 4, so double this guy right here. We're all the way up to 8 already. And y of 3 is going to be 2 times 3 squared, which is 2 times 9, which is 18. So way, way up here. We've already run out of space. So that's what our parabola is going to look like for y equals 2x squared. And similarly, it's going to be a reflection on the other side, because when you square a negative number, you still get a positive, so it may as well have been positive to begin with. Okay, so that's the parabola y equals 2x squared. Let's do a quick summary. Hopefully that was reasonably clear. Let's summarize now. So if our parabola takes the form y, a parabola is of a function of the form y of x equals k x squared, where k is some constant. Remember, k can't be 0, otherwise it's not a parabola. If that's the case, then we've got kind of two cases. Suppose that 0 is less than k is less than 1. Well, if k is between 0 and 1, then multiplying by k is basically the same as shrinking it. Think about if you multiply by 0.5. That's the same as cutting it in half, right? Well, actually, for any k between 0 and 1, you're actually reducing it when you multiply by k. So when you reduce it, the parabola... running out of room there. The parabola will become fatter. Because if all of a sudden the y values are reduced, then it's going to take more time to increase. It's going to need higher values of x to reach higher y values, and that results in a wider, fatter parabola. How about if k is bigger than 1? If k is bigger than 1, then we're actually increasing our y values. We're increasing everything, so that's going to result in a longer, skinnier parabola. So the parabola becomes longer and skinnier. How do you spell skinnier? S-K-I-N-N-I-E-R? I don't know. Skinnier. Anyway, so if k is bigger than 1, the parabola becomes longer and skinnier. So this constant controls how wide it is. How wide is the parabola? There's one more case, though, that we didn't really consider. What is that case? K negative, so k less than 0. What do you think is going to happen if k is less than 0? Well, let's actually find out. Let's do one. So, before I do anything, I'm going to draw the parabola. So here's x, here's y. I'm going to go ahead and draw the parabola y equals 1/2 x squared. So this is y equals 1/2 x squared. Notice that it goes through 0, 0. Okay, now we're going to go, well, first let's put in some values, I guess. So suppose this is x equals 1, then this must be 0.5. and this I guess is x equals negative 1, x equals negative 2, then y is going to equal 2. And that's the same as when x equals positive 2. Okay, well that's all well and good. We know what half x squared looks like. Let's now draw the graph of y equals negative 1/2 x squared. Let's find out what this thing looks like. Well, first of all, when x equals 0, negative 1/2 times 0 squared is still negative 1/2 times 0, and anything times 0 is 0. So we're still going to go through the point 0, 0. How about when x is equal to 1? Well, when x is equal to 1, y is going to be equal to negative 1/2 times 1 squared. So negative 1/2 times 1, so still negative 1/2, or negative 0.5 if you like. Negative 0.5. So when x equals 1, y equals negative 0.5, and we go through this point here. Similarly, when x equals negative 1, we're going to get the same thing, because negative 1 squared is still 1. Okay, how about x equals 2? If x is equal to 2, then y is going to be equal to negative 1/2 times 2 squared, which is negative 1/2 times 4, so negative 2. So we're actually going to go through this point. And similarly, when x equals negative 2, y is still going to be equal to negative 2. And maybe you've picked up on it now. I really wish I hadn't drawn this where I drew it. But what happens when you multiply by a negative constant, when you multiply x squared by some negative k value, it's actually the same as if k were positive, except flipped up the other way. So it's the same as the graph we drew above, except reflected in the x-axis, because all the y values are now negative instead of positive. So really, all that's happened is this graph has flipped upside down when we introduced that negative sign right there. Okay, so that takes care of the case when k is less than 0. You just imagine k was bigger than 0, and then in your mind flip it upside down because all the y values are negative. Alright, I guess that'll do for this section. Thanks very much for watching. Don't forget to check out the notes that go with this section. You can download them below the videos. So yeah, do that. Maybe have a go at some of the exercises if you want, if you've read through the notes. And I will see you for the next section on parabolas. Take care. Bye.